So hopefully by now we know a lot about linear relations. We're very comfortable working with them. And hopefully you're so comfortable working with linear relations that you can work with two linear relations at the same time, because that's what we're going to do in this lesson. Okay, so when you work with two or more linear relations at the same time, what we have is a linear system. Okay, so we're going to take it slow. We're going to go over this example, and hopefully our first linear system experience is a great one. So Andrew is shopping for a new cell phone plan. He must choose between the following options. Option A, he's charged 50 cents a minute. Now whereas option B, you have a monthly fee of $20 plus 25 cents per minute. So I want you to take your time and read option A and option B again to yourself. And then, once you understand what both options are giving you, I want you to choose option A or option B. Which one is the better option? Which one is the better option? If you were asked, which one would you choose? Would you choose option A or would you choose option B? So when I ask this to my class, I would argue most students will choose option A, but I would then argue if there is a person who talks for a very, very, very long time, okay, wouldn't option B be better than option A? Right? Because option A is 50 cents per minute, whereas option B is 25 cents per minute. The only reason option B is not as good as option A is because of this initial monthly fee of $20. So hopefully you can say this. Option A is better in the beginning, but after a certain amount of time talking on the phone, option B will become better. Okay, so if you even want to shorten that idea, you can say if you don't talk much, option A is good. If you talk a lot, then option B is good. The problem with that is, what is a lot? Okay, there must be a number that goes from A being better to B being better. So our goal here is to study this linear system, which is these two linear relations together simultaneously, and understand what is that point where B becomes better than A. So we're going to use our table just to make sure we understand the two scenarios or two options clearly. So option A, it's 0 minutes, no cost. 10 minutes, if you take 10 and 50 cents a minute for 10 minutes, that's $5. Another $5, $5, $5, $5. Okay, every 10 minutes is an extra $5. Whereas for B, right off the bat, bam, $20. Okay, and then $22.50 because it's 25 cents a minute. So for 10 minutes, that's $2.50. That's $25. $27.50. 30. $32.50. Okay, so if you talked for 50 minutes over the month, okay, over the course of a month you talk for 50 minutes, clearly option A is better. Okay, option A is better because it only costs $25, whereas option B for 50 minutes costs $32.50. But as you can tell, the difference, in the very beginning, the difference between the two costs is $20. But here it's shrinking. It's only $7.50 now. So B is gaining on A, but the question is, how long will it take? So now we're going to graph the two options. So I'm going to graph option A first. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You could just plot 2 points, but I really want it to be as accurate as possible. And I'll tell you why I want it to be accurate as possible. Okay, so this is option A. What about option B? Whoa, starts off at $20. 20 minutes, 5. And that's why I wanted to plot as many points as I can, because I'm trying to look for where these two lines intersect. Because when it comes to working with linear systems, where the two lines intersect is very, very important. So I'm going to write down the ordered pair of this point. This is called the point of intersection. 80, 40. Very important point, because that point is going to tell us which option is better. Okay, so which option is the better buy? Let's look at the graph. If you're talking for less than 80 minutes, which one is cheaper? Which line is lower? Clearly, option A. So option A, if you talk for less than 80 minutes. And option B, if you talk for more than 80 minutes. What if you talk for 80 minutes exactly? Well, if you talk for exactly 80 minutes, both option A and B charge you $40. So it doesn't matter. If you talk for exactly 80 minutes, option A and B is identical. Okay? So either options, if you talk for 80 minutes. So that covers all our bases. Less than 80, more than 80 or greater than 80, and exactly 80. Okay, there's no other scenario you can create here. So one more time, less than 80 minutes, option A, which that's exactly what we said in the beginning. But instead, in the beginning, we said, if you don't talk much, choose option A. If you talk a lot, choose option B. But this is much better. What is not much, right? That's not a number. So now you know exactly. You can plan out your choice. Less than 80 minutes, choose option A. More than 80 minutes, choose option B. And if you talk for exactly 80 minutes, it doesn't matter which option you choose. Okay. So we have here, the boss student council is planning a semi-formal. Which hall is the better buy? So you have the radical room and the happy hall. So first I'm going to identify where these two lines intersect. So that's 175 and 2,250. Okay, so what does that point of intersection mean? It's really important that we can interpret that. This point means that both radical room and happy hall both cost $2,250 if 175 guests come. Okay, so by the way, radical room is a direct variation and happy hall is a partial variation. So that means that radical room is cheaper in the beginning. And when I say in the beginning, that means less than 175 guests. So radical hall is the better buy. If there are less than 175 guests. Oops, radical room. Happy hall is the better buy if there are more than 175 guests. and at 175 they're the same value. So if 175 guests come, both cost $2,250. Okay. So assuming that the two halls, the Radical Room and Happy Hall, are truly identical, okay, there's no difference whatsoever. That's a very important point. If Radical Room looks better, then this argument is moot. Okay, we're only talking about price and the guests, because if there's any difference between the rooms, then it's hard to make this comparison. Yeah, so the better buy is Radical Room if it's less than 175 guests, and Happy Hall is the better buy if there are more than 175 guests. But one more time, I have to state, there's nothing else that's different between the two rooms. Okay, like even our previous question with the cell phone plan, you can't be talking about different companies. It has to be the same company, because for example, if one was Rogers and one was Freedom Mobile, yeah, they're offering the same service, but there are differences between the companies. So yeah, so we're gonna make the assumption that Radical Room and Happy Hall are truly the same. Okay, let's go. One more example, one more linear system. Ooh, we have 3 linear relations. Beautiful. So Friendly Fitness offers its members 3 different payment options. Okay, so Amanda is trying to choose between the 3 options. So we have the number of visits and the costs. So I'm going to identify the key points here. Okay, I'm going to use a different color. So what you want to do is you want to take a look at this graph and you want to establish when is it the cheapest option, or what is the cheapest option based on the number of visits. Okay, so in the very beginning, from 0 to 4 visits, okay, from 0 to 4 visits, the cheapest option is option B. And then option B is no longer a good option after 4 visits. This option is better. Okay, and then the list is that option. So you want to go with whichever line is the lowest. Okay, because in this case the lowest is the cheapest. So from 0 to 4 visits, option B, listen to 0 to 3 visits, option B, option B is the better buy. For 4 visits, either option B or C. Okay, because at 4 visits, both option B and C cost $40. Let's see, from 5 to, this is 12 here, right? So that's 11. From 5 to 11 visits, option C is the better buy. Okay, for exactly 12 visits, either option C or A? Let's do A or C instead. Okay. Why A or C? Because at 12 visits, both A and C cost $80. More than 12 visits, option A is the better buy. Okay. So what Amanda has to, is it Amanda? Yeah, what Amanda has to ask herself is how often does she plan on going to the gym? If she doesn't go very often, let's say 0 to 3, then she should choose option B. Okay? And if she plans on going between 5 to 11 visits, then option C is the best. And then if she goes to gym every day of the month, then she should go with option A. Okay? But option A would be a horrible idea if she only went once. Okay? So that's linear systems in a nutshell. We hopefully you're very comfortable with individual linear relations, and when you're comfortable with that, then we can progress to linear systems and answer very interesting questions. You can make wise decisions when you look for where the two linear relations intersect, because that point of intersection is very, very meaningful.